Let me be the first to congratulate you for making it this far in this course. I'm really proud of you. I'm glad you're taking my course and I have a bit of a favor to ask. You see, I've come into a lot of money and I myself can't move it out of the country because it may raise suspicion. So I really need somebody else to help me. And all I really need is for you to send me your bank account information and maybe $2,000 to cover the taxes. And I promise you, I'm going to split it with you 50-50. So does that sound familiar? Well, we call that phishing. The idea behind that is somebody's trying to get you to part with your personal or financial information. And I can assure you that in the history of people wanting to give away money, I doubt that anybody has ever actually received any money through that method. And so why do we call it phishing? Well, the origins date back to the wares community on AOL in the mid-90s. And wares is a term that's used to represent software obtained illegally without proper licensing. And at the time, a popular AOL feature was chat rooms. And the wares community had their own chat room. And chat rooms are kind of like an IRC or maybe a modern day Slack. Now, AOL enforcement would try to detect the words that these wares communities would use and identify their accounts and suspend them and try to shut these accounts down. So the wares community would use codes to represent certain topics. And one such code they came up with was this. It was chosen because it was the single most common HTML tag, and it was found in chat scripts naturally, so it couldn't be detected by the AOL filters. And it was used to replace any word referring to stolen credit cards, stolen software, accounts, or other illegal activity. And due to the popularity of phreaking at the time, which is a form of telephone-based hacking, the PH was added for extra coolness, and the term phishing stuck. The reason I talk about phishing is it's a very common way that systems can become compromised to participate in something called a distributed denial of service attack. Now, the first demonstrated denial of service attack was made by Con C. Smith in 1997 during a DEF CON event in Las Vegas. And he denied the Las Vegas Strip for internet for over an hour before people figured out what was going on. And in general, you have a bad actor that sends commands to these compromised machines, and then they will do something that will impair the targeted device, either overwhelming it with traffic or sending lots of requests to it. And it lowers its performance, and it could potentially cause an outage. In extreme cases, it can expose sensitive data. Now, a type of denial of service attack is called an amplification or a reflection attack. An NTP, which is the Network Time Protocol service, has this command built into it called monlist. And it was built in there to help with monitoring. And what it does is it returns the last 600 IP addresses that it's talked to. Now, a bad actor can spoof a packet. In other words, they can manipulate a data packet to make it look like that packet came from some other device. So they would send this spoofed packet into an NTP server, and that NTP server would send back a message that's many, many times larger to the spoofed address. And so, of course, that has the effect of potentially overwhelming the target. Now, if you recall back to our OSI model, layer 7 is the application layer. And there's something called application attacks. And generally, these are attacks that happen like at HTTP, where a bad actor would flood a target web server with GET requests that would push up the utilization of the network coming into the web server. It would push up the utilization of the web server, and also maybe if it's back-ended with a database. And it would have the effect of creating an outage or a very slow delay to a legitimate web client that's trying to access that same web server. Now, there are a few things that we can do on AWS to help mitigate distributed denial of service attacks. So first and foremost, we can minimize our attack surface. And following the principle of least privileges, we can lock down our NACLs and our security groups to only allow that traffic in from the public internet that we need to. Second, we can be prepared to scale to absorb the attack. So we can use stuff like auto-scaling groups and CloudFront, and we can put our static content on S3, and that will easily absorb any sort of DDoS attack. And we also want to be able to safeguard any exposed resources, and we can use AWS Shield or the Web Application Firewall. And we can even also use Route 53. We can use regionalized routes to maybe restrict certain geographies from hitting our application or our website. And it's also important that we get a baseline. We learn what normal behavior is, and we can do this through GuardDuty and CloudWatch, so that when something abnormal happens, we're able to put some alarms around it. And finally, most importantly, we have to have a plan. So when we see those alarms, we know what we're going to do. We know what steps we're going to take to help mitigate that denial of service attack. Now, here's an example of a web architecture that is pretty well prepared for a denial of service attack. We're going to use CloudFront as our CDN, so we're going to serve up all our static assets and images from there. And we're going to have a web application firewall in front of our web server. We're going to have an elastic load balancer with an auto-scaling group behind it. And we're also going to use DynamoDB because DynamoDB scales very rapidly and very robustly.